Hello, welcome to the video. In this section, we're looking at 9.5, where we're going to be solving quadratic equations using the quadratic formula. So again, more different methods for using or discovering what the x-intercept is for any particular quadratic function. Up to this point, from this point, we've been given different methods in order to find the x-intercepts. The problem with those different methods is we were given a stipulation. All right, it was like factoring had to be something you could easily factor. Square roots, b had to be 0. Completing the square, a had to be 0. Now, uh, to finish up, the last method in order to discover what an x-intercept is by using the quadratic formula. The best part about using the quadratic formula is it works for every single equation. All right, it doesn't matter if a is 1 or negative, if you can factor it, if you can't factor it, if b is 0, if b is a number, doesn't matter. You're going to get a result, or at least be able to discover what the result is by using the quadratic formula. All right, so once you have it set up in this form, ax squared plus bx plus c, this is our formula. All right, it's going to be x equals the opposite of b, which is right here, plus or minus the square root of b squared, which is the same value of b, minus 4 times a, which is right here, times it by c, and the whole thing's divided by 2 times a, which is right there. Okay? That is going to determine what our x-intercepts are. All right? With this plus or minus, shows us that we're going to get the possibility of having two solutions. And I'll show you what it looks like. And I understand that this formula looks very daunting just because of all of the different variables and square roots and stuff like that. But if you break it down, it's really not too bad. All right, it's really not too bad. So if we look at this particular equation, we have 2x squared minus 5x plus 3 set equal to 0, and they want us to use the quadratic formula. All right, anytime you are asked to use the quadratic formula, please be sure that you set your equation equal to 0. Make sure it's set equal to 0. It's set equal to 0, so we're good. All right, what I would suggest for you to do is to tell me what A, B, and C are going to equal. All right, A in this case will be 2, B is going to be a negative 5, and C is going to be a positive 3. All right, now if you want to write out the general formula each time, if that helps you, I encourage you, but I'm just going to fill in as we move. So it's going to be x equals the opposite of b, so b is negative 5, so the opposite of that is positive 5, plus or minus the square root of negative 5 squared is 25, um, minus 4 times a, which is 2, and c, which is 3, and the whole thing's divided by 2 times 2. Okay, so the very first thing you're going to do once you've substituted all of those numbers in for the values of a, b, and c, is you're just going to look inside the square root first. You're going to solve what's inside the square root. So inside the square root, I have 25 minus 4 times 2 times 3. So order of operation inside that square root is we must take care of the multiplication. So I have 5 plus or minus the square root of, and I'm just going to put the 25 right there. So negative 4 times it by 2 times it by 3 gives me negative 24, so minus 24. And then you can take 2 times 2 and make that 4. All right, so you can take care of that. 25 minus 24 is 1. So now I got 5 plus or minus the square root of 1 all divided by 4. But what is the square root of 1? Square root of 1 is perfect square number. So now I got 5 plus or minus 1 all divided by 4. All right, sorry. So after we square root the 1, I have 1 plus or minus 1 all divided by 4. So what this is essentially two different problems. So what we have here is 5 plus 1 divided by 4 and 5 minus 1 divided by 4. That's where the plus or minus comes in. That's what that means. So here, 5 plus 1 is 6. 6 divided by 4 is, 3 halves. 5 minus 1 is 4. 4 divided by 4 is 1. So my two answers are 3 halves and 1. So my two x-intercepts would be 3 halves comma 0 and 1 comma 0. So that's how you'd use the quadratic formula to create those. And again, take a look uh, at these examples. You're going to be asked to use the quadratic formula. If you have any additional questions, uh, let's let's look at number 2. Let's look at number 2, and then we'll go from there. Let's say so a is 1/2, b is 1, and c is -10. So if I plug this into the quadratic formula, let's go opposite of b, which is -1, plus or minus the square root of 1 squared, which is 1, minus 4 times a, which is 1/2, c, which is -10, and it's all divided by 2 times a, which is 1/2. So I go here, I got this -1 plus or minus. I take care of what's inside of the square root. So got to take care of the multiplication. So I got -4 times it by 1/2 times it by a -10. So that's 20. So now I have the square root of 1 plus 20, and it's all divided by 2 times 1/2, which is 1. So now here I have -1 plus or minus the square root of 1 plus 20, which is 21, and it's all divided by 1, so I'll just leave it like this. So now square root of 21 is about 4, so they want us around to the nearest tenth, so it's going to be -1 plus or minus 4.6 about. All right, so -1 plus positive 4.6 is going to be 3.6. So I got 3.6 as one answer, and -1 minus 4.6 is -5.6. So there is our two solutions. And again, if you have questions with any of these others, more than happy to do that. Just leave me a comment and I can answer those questions. So here is another way that you can use the quadratic formula other than attempting to find the x-intercepts. So here it says the number y of northern Rocky Mountain wolves breeding pairs x years since 1990 can be modeled by the function y equals 0.2x squared plus 1.8x minus 3. They want to know where they were, when were they about 35 breeding pairs. So you can look at the graph here and say, okay, where's 35? I would say, well, this is probably where 40 is. And so I would say this is where 35. So I would say it is right in here. So in between 9 and 12 years. So if 0 is 1990, this is 93, this is 96, 99. this would be what, 2002. So somewhere between 1999 and 2002, or I'm sorry, 2012 is going to be our answer. So what we have to do is we have to find that value for x. So what we are going to do is we are going to replace y with 35 because y determines the number of breeding pairs. So this is going to be 35 is equal to 0.2x squared plus 1.8x minus 3. So what we're going to do is we're going to set the equation equal to 0. So it's going to be 0 equals 0.2x squared plus 1.8x. And then negative 3 is going to be subtracted by, what, 35. So now I get minus 38. So we can use the quadratic formula here to determine what my values for x is going to be. And so let's take a look here. This one is going to be a is 0.2, b is 1.8, and c is negative 38. So I go negative 1.8 plus or minus the square root of 1.8 squared gives us 3.24 minus 4 times a times it by c, and I'll divide it by zero point 0.2 times 2, and that's going to be 0.4. So if I look inside, I got negative 4 times it by zero point 0.2 times it by negative 38. I get like 30.4, so negative 1.8 plus or minus square root of 3.24 plus 30.4, all divided by 0.4. So looking at this, 3.24 plus 30.4, I get 33.64. Taking the square root of 33.64, I get 5.8. So negative 1 plus or minus 5.8, all divided by 0.4. So the only one I'm really looking for is the positive x. So the plus is the only one I'm going to really look at. So negative 1.8 plus 5.8 is 4. Divide that by 0.4, I get 10. So x is 10. So that means that where it hit 35 would have been 2010. The last concept that we're going to look at in this section is being able to what is called interpret the discriminant. So if you notice, let's look at the very first section here. What's inside um, the square root is b squared minus 4ac. All right. And so if you notice, that is what the discriminant is, b squared minus 4ac. And all this does is it shows, does it have two solutions, one solution, or no solutions for your x-intercept? All you're going to look at is you're going to plug in the value for the discriminant. So you're going to use b squared minus 4ac with your general quadratic equation, values of a, b, and c. If your result is positive, then it's going to have two solutions. It's going to have two x-intercepts. If the result is 0, you have 1. So keep that in mind. Even though the result of your discriminant is 0, it's actually one solution. And if you have a negative result for your discriminant, you have no real solutions or no x-intercepts. So here they're asking us to determine the number of real solutions. So we have to use the discriminant, the b squared minus 4ac. B is 8, so I got 8 squared, which is 64, minus 4 times a, which is 1, and c, which is negative 3. So I got 64, and then negative 4 times it by 1 times it by negative 3 is 12, so it's plus 12. 64 plus 12 gives me a result of 76. It's positive. I have two real solutions because my discriminant was positive. If I look here, I have this equation. So again, put it in here. B is -6, so b squared will be 36 minus 4 times a, which is 9, and c, which is 1. So this is a situation where I get 36, -4 times 9 times 1 is -36. My result is 0. Because my result is 0, I'm going to have one solution. Remember, just because it's my discriminant is 0 doesn't mean I have 0 solutions. It means I have one solution. So keep that in mind. Looking for this one, they're asking you to find the number of x-intercepts. That's the same thing as number of solutions. So again, you're using the discriminant, b squared, so it's going to be 9 minus 4 times a, which is 2, and c, which is 9. So I have 9, and it's going to be -4 times it by 2 times it by 9. I get negative 72. 9 minus 72 is negative 36. It's a negative number. I have 0 x-intercepts. So this final little chart here is just talking about the different ways of discovering what the x-intercepts are. Um, More often than not, I would say when you are trying to find x-intercepts, you're either going to use factoring, using square roots, and using the quadratic formula. All right, I would say that those are going to be the three most common ways that you are going to go about finding the x-intercepts. All right, you may be asked to graph it, but I am you'll be probably using one of the three methods when you graph it. And that is being able to solve equations using the quadratic formula. I hope this helps. Until next time.